In this lab, we will measure the momentum of a ball leaving a spring gun in two ways. First, by firing the ball into a pendulum and measuring the maximum angle, and second, by firing the ball off a table and measuring the range. First, you will measure the outcome of an inelastic collision with the ball and pendulum and relate the maximum angle reached by the ball and pendulum to the ball's initial momentum. Let's first derive an equation for this relationship. Initially, the catcher and ball are stationary. The ball then leaves the gun with an initial momentum equal to the mass of the ball times its velocity. As the catcher is stationary, this is also the total momentum of the system. Immediately after the collision, we set the momentum equal to the total mass of the ball plus catcher times the velocity. In an inelastic collision, momentum is conserved. We set the two momenta equal to each other and solve for the initial velocity in terms of the final velocity. Kinetic energy is not conserved in this collision. After the collision, the energy of the ball-catcher system is conserved. We set the initial height of the catcher to 0, giving us 0 potential energy. The total energy of the ball and catcher at this point is just the kinetic energy. At the pendulum's turning point, all the kinetic energy has been converted into potential energy. We can then rate the change in height in terms of the length of the string and the maximum angle theta. As the energy is conserved, we set the energy at these 2 points to be equal. We can then obtain an expression for the velocity of the ball and catcher just after the collision. We can then solve for the velocity of the ball as it's leaving the spring gun in terms of the measurable quantities L, theta, and the masses of the ball and catcher. The initial momentum of the ball is then just the velocity times the ball's mass. Now let's look at the experimental setup. First, check that the catcher is aligned with the spring gun. If not, adjust the lengths of the strings so that the catcher is aligned. The catcher should only move in the plane of the protractor. If not, some of the ball's momentum will go into twisting the catcher. When measuring the maximum angle, make sure to look at the protractor head-on. Parallax will cause the string to appear as if it is in a different position when viewed from other angles. To use the spring gun, place the ball on the end of the barrel and push back until you hear a click. Hold firmly with your other hand as the base tends to move. Once the gun is cocked and the catcher is aligned, pull the trigger to fire the ball. Read off the maximum angle reached by the pendulum. Be sure to look head-on to avoid issues of parallax, and record this angle for 10 trials. You will do a second experiment to measure the initial momentum of the ball by firing it off a table and recording the range. We will derive expressions for the ball's initial momentum in terms of the measurable variables range and height. Since this is a projectile motion problem, we will break things down into the x and y direction. In the y direction, we can solve for the time of the ball's flight using the acceleration and distance traveled. The ball starts off traveling in the horizontal direction, so its initial y velocity is 0. In the x direction, we can relate the range to the initial velocity using the time calculated in the y direction. As we are neglecting air resistance, we will assume the acceleration in the x direction is 0. We can combine these equations to find an expression for the initial momentum of the ball only in terms of the measurable quantities range, height, and mass. To set up for the projectile motion experiment, place a piece of tape on the table and line up the feet of the platform with this tape before each firing. Cocking the gun will cause the platform to move, and placing a piece of tape will allow you to line up the platform so that you can measure the range from the same point for each trial. Use the plumb bob to check that the platform is level. Tape a piece of paper to the floor where the ball will hit. The ball will make a dent in the paper, which will allow you to measure the range. Fire the ball off the table 10 times, recording the range for each trial. Find the mean and standard deviation for the measured momenta in each experiment. How do your results from the two experiments compare? Can you account for these differences?